Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson, we're going to look again at systems of nonlinear equations, and we'll be using the GaussSeidel technique, or successive substitution. Again, we're looking at a system of nonlinear equations, and if we have n unknowns, we need to have n equations. And the way to set them up is so that they are all arranged so that they are something equal to 0. And if any one of these pieces is nonlinear, then the entire system is considered to be nonlinear. Now, we've done GaussSeidel iteration for linear systems, and really the technique is the same. But it's really going to be very critical how you arrange the equations. So if you'll recall, the technique is basically to take your equation and solve for one instance of your variable x and one instance of your variable y using different equations, and then just use those iteratively to continue with your solution. A good first guess matters, and which form of the equations you use makes a big difference. So this technique doesn't have to work, but it frequently does if you do the setup properly. So let's look again at our system of equations that we were doing with Newton-Raphson earlier. We're going to use the same starting guess and the same two functions. In this case, I want to solve these equations for one of the instances of the variables. So let's just solve for x here. Seems easier to do this one than the square root. And solve for y with this one. So these are my forms that I'm going to use. So I'm going to solve for this x in terms of 10 minus the old x squared over the old y. This will now become the new old x, and so my y will be 57 minus 3, the most recent guess of x, times the old y squared. Let's look at this in Excel. So I have my two starting values here, and I just simply need to use the formulas. So the first time x is equal to 10, well, I need parentheses, 10 minus the x answer squared divided by my last y. And this is the x. I now want to do my y. And y is equal to 57 minus 3 times x, and I want to use the most updated version of x, times y squared, again using the most updated version. And I can simply copy these until it gets an answer. And as we can see, this one isn't doing it. So what is my solution? Well, I could try different starting values. In fact, I know the answer is 2 and 3, so let's put in 2.1 and 3.1. But that doesn't really seem to help. So my other possibility is that I can work with different forms of the equation. So since that didn't work, let's go back to our equations. And if I take this and solve this time for x, and I guess I'll have to do the square root of 10 minus xy, and y is 57 minus y over 3x, the square root of that, then I can return to my Excel and let's see how it does this time. And again, I'm going to put in my starting values that I started with. My x is equal to the square root of 10 minus x times y. Y is equal to the square root of 57 minus y over 3x. This seemed to get to closer to what we know is the correct answer. If I look at copying this, you'll see that we get to pretty close to the correct answer, and it doesn't take too many iterations. Okay? So we've seen this where it diverged, and we've seen it where it converged. So this wraps up our discussion of numerical integration. In our next lessons, we're going to look at curve fitting. Thank you very much for your time.